Department of College and Technical Education have been set up a program on online classes for diploma students with the help of LMS system. So here we will start the 9th session on design of fasteners, unit 2, where we come across the problems on riveted joints, lap joint and butt joint. The table of the content, topic 1, procedure in the riveted joints and simple problems on lap joint and MCQs. Design procedure in the riveted joints. Select the type of the joint, whether it is a lap joint or a butt joint. Then with the help of the unwind formula, determine the diameter of the riveted hole if the thickness is greater than 8 mm, and if the thickness is less than 8 mm, you compare the crushing strength with the shearing strength to get the riveted hole diameter. After getting the values of riveted hole, next you go for finding the pitch by comparing the tearing strength and the shearing strength. With the help of the tearing and the shearing strength, comparing both of these, you will have the value of the pitch. So by this pitch and the standard values provided in the design data handbook by the author Madhavan, you just compare both the pitches, whichever is the least, take that value for further calculation. Then we go for finding the transverse pitch, whether it is a chain or a zigzag manner of rivets. I think already you have studied about the basic knowledge of the rivets, that is a rivet having a 3 parts, head, shank and a tail. Basically the shank diameter is considered for calculation, or to get the design we will take or will adopt the diameter of the shank in our design procedure. So then we go for finding the margin of the particular riveted joint, that is given by m is equal to 1.5d, that is there in our data handbook. After calculating all the parameters, we have to compare these parameters with the stresses available to get whether the stress is feasible or unfeasible for that particular dimension. So we have generally 3 formulas, so that is on the basis of tensile, shearing and compressive or crushing. And once we got the value of the feasibility, we further go for calculation the efficiency of the joint, whether it is efficient or it is inefficient to be utilized on this dimension. So by these parameters we come to know that the joint whichever we want to make it, that is the riveted joint, it should be within a feasible limit. So let us do a few problems on this topic, so that we can clearly understand what is there behind the problem. Before that, we have to know some thing about the tearing, steering and crushing. So let us just go through by the diagrams which are there. That is the plate. Basically the plate will tear due to tensile strength. It may be at the margin, that is the margin is given. The margin is m here, where the plate, if the margin is less than 1.5d, the plate will tear or failure occurs. And similarly the plate will tear at the row of the rivets. So just we can see that the row of the rivets, some curved lines are shown in the figure. This indicates that the plates will tear in this way also. due to the dimensions of P minus D, where P is pitch and D is the diameter of the riveted hole. If the value is very narrow, very least, then automatically a tearing of the plate will occur. Then we have the shearing. Shearing in the sense the rivet itself will be breakdown or dismantled or broken into two pieces, as we can see here. These are the two main plates of lap joint, and this is a butt joint where we have two main plates along with the cover plate or strap. Single cover we are provided here. Where we speak, this is a single riveted lap joint, and this is also a single riveted single cover butt joint, where we come across a single shear on both these type. If one more cover will come beneath this, then we will say it as a double shear. Means the shear occurs on the double side of the riveted joint. Coming to this picture, we can see that the rivets have been totally broken down due to the shear strength. So then we have a crushing. So due to the plate, there may be bulges, or the rivets may get slackened down due to the bulging of the plates, and crushing will, due to crushing load, the plate will crushed off. So then coming to the problems, we have some problems on single riveted and double riveted lap joint. In this session we will do a few problems. So here the session has been divided into 4 units, that is 4 hours, 4 parts. So the first part is just introduction of the procedure for the how to solve the problems, and along with that a simple problem, then MCQs will be there. Then in the second and third and fourth session we will have the remaining problems on the riveted joints, that is single and double, along with single plate, double single riveted, double riveted, single strap, double strap, lap joint and butt joint. Okay. So coming to the problems, just to go through the problems, it is clearly mentioned that it is a single riveted lap joint. It is single riveted lap joint. There a lap joint is provided in this problem in 15 mm thick. In the plate used here is thick for 15 mm, means T is 15 mm. With the diameter of the hole is already given, that is the diameter of the rivet is given, that is D is equal to 20 mm, and pitch is also given. If the pitch of the rivet is 60 mm, find or determine the strength of the joint. Along with that, some stresses are given. The stresses are like this: tearing stress or tensile stress, that is given by the symbol sigma T, or you can also write it as Ft, small f with the suffix T, 120 megapascal. So megapascal should be converted into normally into Newton per mm square. So the basically megapascal can be directly converted into Newton per mm square, that is 120 Newton per mm square is the answer. Then we have shear stress, that is tau. The symbol for it is tau, or you can use it as Fs, small f suffix s, and the value is given is 90 megapascal. Then we come to the crushing or compressive or bearing, one and the same. It is also given by the symbol sigma c, or you can also use f of c, that is small f suffix c, where we have the answer 160 megapascal. First of all, you have to write all the data given clearly, noticing that whatever there in the problem, you just go through it, just write down all the parameters. Clear? Then you see that whether it is a lap joint or a butt joint, because it is really important. If it is a lap joint, then it is basically it is considered as whatever may be the number of rivets. Lap joint comes under single shear, whereas in the butt joint we have to see whether the plates, that is the cover plates which will cover the main plates, whether it is a single or a double cover. If it is a single cover, no doubt it is a single shear. If it is a double cover, then we have to think about a double shear, where the equation little bit changes, that is multiplies with the, it becomes the twice. The shear strength, while calculating the shear strength, the equation becomes twice in double shear. But single shear, it remains identical what is there in our data handbook, but when the matter comes under double shear, we have to just multiply by twice. Clear? So for that purpose, it is very important to understand that what type of joint is given, whether it is a lap joint or a bed joint. If it is lap joint, we write it as a lap joint, and then you see that what type of rivets, whether it is a single rivet or a double rivet, he has mentioned. So here in this problem he has mentioned single rivet. So we have written, or I have just mentioned that n is equal to 1. That is very useful in the coming equations. So we have to refer the data handbook, design data handbook provided by the by our Directorate of Collegiate and Technical Education Department. There is the Mahadevan, that prescribed book, that is a reference book, what is given in our syllabus. By that book only we have to use, and we have to refer in our working time. Then that book is basically submitted, or basically issued at the time of the exam hall also. So if we have to work out thoroughly, we should work on the book, so that it is easy to understand each and every parameter at the working place and also in the exam hall. Both will become very easy. So better refer Design Data Handbook by Mahadevan. Okay. Then coming to the equations, there are 3 equations as I told you. That is, one is tearing strength, to find the tearing strength, shear strength, and compressive strength or crushing strength. The equations is like this. That is given by the number. That is 5.11. His name is just we have to write the book name, Design Data Handbook. Equation number 5.11. That is page number 63. We have mentioned that in the in this unit. Just mentioned that we have to mention it so that it will be clear. So now substitute the value of pitch, diameter, thickness, and stresses. It is 60, that is given. 60 minus 20 and 15 is the thickness, along with the 120 stress. The answer will be 72,000 Newton for tearing strength. Similarly, we have to calculate the shearing resistance or shearing strength of the rivet. That is given by the formula PS is equal to pi by 4 d square tau into n. That is equation number 5.13. and the page number is 63, where n is 1. So we have just not mentioned that one. Okay. Coming to the next, we have the values. That is pi by 4 into 20 square, 60. 60 is the stress, shearing stress, and 20 is the diameter of the riveted hole. Then the answer what we got is PS is 28,274.33 newtons. So next the step is to find the value of crushing strength or crushing resistance of the riveted joint. That is also given by the equation 5.14 of the Design Data Handbook. That is the page number, in the page number 63, where we have PC is equal to ND T sigma C, where N is 1. Just I have not mentioned, that's all. Okay. So N means number of rivets, row. Single riveted means only one row of rivet are there. Double rivet means two set of rows are there. Therefore we have to consider at the time of N2. N2 is equal to 0 here, and N1 is 1. That is there in the equation. 20, 15, 160, 20 diameter of the riveted hole, 15 is the thickness, which is multiplied by 160, that is the stress of the crushing or compression, the total answer of the PC is 48,000 Newton. So finally he has asked to determine the strength of the joint. The strength of the joint can be determined by the by just comparing all the three values, that is the strength, PT, PS and PC. Out of these three values we have to consider only the least value, whichever is least, whether it is a PC, PT or PS, whichever is the least, that value you have to consider to show the strength of the joint. Okay, here in this problem the strength of the riveted joint is 28,274.33 is the answer. Okay, so this is the problem what he has asked, and we have gone through the problem completing this. It is very easy problem, so you just go through it, practice one or twice, it becomes very easy for you. So next, coming to the MCQs, so basically MCQs are provided here in this session. So according to the Unwin's formula, so I think this is just we have studied in our previous classes, where Unwin formula are used to find or to determine the diameter of the hole whenever the thickness is provided. So that is directly given by the Unwin formula. With the thickness is given, so no other parameters are given, then we have to use this formula that is given by 6 root T. The answer is 6 root T. A lap joint is always in a dash shear. So just I told you, the lap joint or a butt joint, we have to think about what type of shear will come. If it is a single lap joint or if it is a single cover butt joint, then basically it is a single shear joint. If it is a double cover, then only we speak about the double shear. So from that it is clear that a lap joint is a single shear joint. Clear? The strength of the unriveted or the solid plate per pitch length is equal to, it is just a efficiency equation where we are going to use this equation with the strength of the riveted joint to the unriveted joint value. That is given by unriveted means basically the plate which is not riveted, only holes are provided, is not at riveted. So that is considered as unriveted. So here pitch is there and thickness of the plate is there. Only two parameters is there, because no rivet will come, therefore diameter is absent here. So we have to consider plate means generally we come across tensile stress. So from that point of view, the equation for this answer will be PT sigma T. PT sigma T is the answer for this question. Okay, so you just go through this and clearly understand and practice, so that you get thorough in this. So a few problems are given for you as a homework. Just it is a very easy problem what we have done. The problem what I have done here, the same problem, just you have to go through it. Here we have thickness 24 is the diameter, D and T is the thickness, and pitch is 60, same which I have given. So along with the stresses are just changed, 120 for tensile and shear got 90 and compressive 160. Go through it and do in the same way, you will get the answer. Okay, do one more problem so that you will get familiar with the problems, the basic problems, how to calculate, how to get the idea of calculation. So here also I have given just thickness 12 mm and 18 mm diameter of the riveted hole along with the 60 mm pitch. Once again the same pitch is given, just changed sigma T 100, tau 80 and sigma C 140. Go through it and practice it. Have a good day.